All right, little request here. 2006, question number 2 with the calculator problem. Haven't done this for a while, but we'll go through it. Intersection in Oregon. Cars turn at a rate of L of t equals 60 t squared t sine squared t over 3 cars per hour. All right, so immediately I see that's a rate. So this is cars per hour, and that means this is hours. So if we do an integral, cars per hour times hours is going to be cars. If I take a derivative of L of t, I'd have cars per hour squared. They give an interval 0 to 18, which is matched on the graph. They show the graph. They say y equals L of t is shown here. Awesome. Has a couple of maxes, has a min. So let's go through and see what it is. So to the nearest whole number, find the total number of cars turning left. Okay, that's simply the integral. The hours are 0 to 18. This L of t is in cars per hour. I would just type that in my calculator, and it's round to the nearest car. Now be careful when you put this in your calculator. Make sure that you're entering it correctly. Don't make a mistake here. And do this on my TI, and I get 1,658 cars. Make sure you include units. This was worth 2 points. The integral is a point, and the cars is a point. So that part of it was pretty easy. All right, and again, units lead the way. So we'll put that up out of the way. Traffic engineer will consider turn restrictions when L of t is greater than 150. So find all values of t for which L of t is greater than 150 and compute the average value. So a couple things going on of L over this time. So I'm going to start with when is it more than 150? First of all, on the graph, I see that there are a couple of times right here where it's greater, where it starts and stops and it's over 150, around 12 and 16-ish. Okay, so I would go to my calculator and I would use I would say L of t equals 150. All right, and I know it's greater in between, so I just want to know those 2 points. And be careful on your calculator, guys. If you put this in your calculator, you can use the intersection of 150 in that, or what I would do is use a solver. But you have to enter this the correct way, which is to say minus 150 equals 0. All right. When I put that in my TI calculator, I get time of, and I go 4 decimal points, 12.4283, and I get a time of 16.1217. And that makes sense on the graph. I feel good about those 2 values. I look here, and those 2 points kind of make sense. I mean, real rough up there, but again, you know that you're on path, and that's a good thing. All right. So those are the 2 values of t. So the interval here would be between, the interval would be those 2 numbers. And I would do t as an element. There we go. That's the answer to that portion. All right. Now we want the average value. The average value of a function, guys, between here. And I'll just use 12 and 16. I know it's not exact. This is the area under the curve. This is the total number of cars. The average value replaces the curve with just some F average here, right? Again, remember this. So I'm going to do the blue integral first. And at this point, maybe I'd call this T1 and T2 up here. And I could write T1 to T2 instead of putting the decimals in. L of t dt. That is the area of the blue curve. The red curve is T2 minus T1. The width of this rectangle right here, just times F average. And now it's a plug and chug exercise, guys. So if I solve for F average in terms of variables, because I probably enter this all in my calculator, and this might be the formula you guys are more accustomed to from your professors or teachers. I like to think of it in terms of the shape and then derive the formula. I don't memorize it. So I do this integral, and I get 199.426. Now, what are the units? Well, the units here, right, are, this is cars, this is hours. So our units on this number are cars per hour. And that makes sense because that F average is on the y-axis there, which has the units of cars per hour. All right, 3 points there. The interval is worth a point. from 12.42 to 16.12, so 4 decimal places though. The F average integral is worth a point, and then finally the number and the units. 199.426 is not good enough. You must have the units also. And it would be arguable I might want to put hours on these 2 times. So, guys, probably should have put hours on those 2 also. All right, last one. Traffic engineers will install a signal if there's any 2-hour period which the product of the total number of cars traveling less than the total number of oncoming traveling straight through the intersection is greater than 200,000. And every 2-hour time interval, 500 oncoming cars travel straight through the intersection. Does this intersection require traffic? So explain your reason. Wow. All right, this one's complicated. The first thing you have to put your arms around is you got to think 2-hour intervals. So right away, I'm thinking over here, I look and I can see the max on the graph of LT is about 14. So I'm thinking immediately that it's got to be around 13 and 15. All right. But here's what you know. You know that the integral, starting at some time t, is some time t plus 2 of L of t dt. This 2-hour interval, that's what this shows. 2-hour interval times 500 has to be greater than 200,000. So I guess I would just go back to t to t plus 2. I would divide both sides by 500. There's no reason for us to carry that around. This is a complicated problem. 200,000 is 400. So I'm looking for anywhere where LT is greater than 400. All right. Oops. Actually, let me move pages. So I'm going back. I'm over a 2-hour period. So I'm looking for anywhere where LT is greater than. See, it's greater than 400 over a 2-hour period. So I look over at 200, and yeah, there's going to be a spot right up here. There is going to be a spot. So now the question becomes, how do I prove that? A couple ways. I bet you could talk about that LT has to be greater than 200 for a couple of the hours. I think that would work. And talk about the 2-hour interval. I would tend to look and say, I know since it's around 14 a max, I would actually take in my calculator and try this. And I'm going to do this. I'm going to do 13 to 15 because we can see the max. I can't stress that enough. We're doing this from visualizing the max at 14 up here. And I would put a question mark. And when I do this, I'll type in my numbers. I love pause. Come back off pause. I get that this is greater. So now I'm going to need a reason. So a traffic light, first one, a light is required. Let's start with that. Boom. Let's make sure we say it straight out because from time equals 13 to 15, L of t exceeds 200 cars per hour. All right, let's see if I did this right. Holy cow. All right, 2 ways to do it. I was right about it. Considers 400 cars. All right, boom. Has a valid interval. It says h to h over 2. I have t to t plus 2. That's the same. Has a value of this whole integral, which I have in 2 spots. So that's the third point. And finally, an answer and explanation, which I have at the bottom. That would be method 1, guys. And I think that's the easier method. This is a very complicated problem. This is one where maybe you start reading, you make sure you've done everything else first. The other way would be to talk about when we got to the point where you could just say L of t, you still have to have this, t is greater than 400, then therefore L of t is greater than 200, and then have a conversation at this point that you can see that on the graph, that at times that the interval around it exceeds that, because it just has to exceed it. I like my method better. It's a little cleaner. It proves the value. This with green, I was just talking, will be a lot of up-down discussion. Again, hard problem. On the AP, you don't have to get everyone right. You got on this one for sure. I think pick up A and B, and that will get you 5 of the 9, and then get the rest right. Get the area between the curves on number 1 right. Get the fundamental theorem calculus problem number 3 right. Work on C. Hardest part here is understand the 2-hour interval, T to T plus 2. I think this is a poorly worded problem, but again, when you're in the test, you just got to do.